to fulfill our Simpsons quote requirement for the episode, we did like 10 takes, and that was the best one.
So hello, everybody. Welcome to OpenCV weekly webinar. Today, we have with us Chris Nogic, who is one of the participants. In fact, he made it to the top 10 of OpenCV Spatial AI competition in 2022. And he'll talk about his journey of creating this submission, which involves a smart AI conveyor belt. So welcome, Chris. I will give you an opportunity to introduce yourself in greater detail. But before that, let me just go over to Phil Nelson, who is the Director of Content at OpenCV. Hello, Phil.
Yeah, good morning, Satya, and good morning to our audience here live from the internet. It is I, once again, the co-host with the co-most, the second banana who is second to none, your plus one and only, the next best thing, Phil Nelson, and I am here to remind you of a couple of things we do every single week here on OpenCV Weekly Webinar, one of which is a special giveaway to you in the audience, one lucky winner. Later in the episode, we'll get a chance to win $200 worth of Microsoft Azure credits from our dear, generous sponsors at Microsoft Azure on blazing fast Intel hardware. We're also taking Q&A from you in the audience, so use that little Zoom Q&A button at the bottom of your screen. If you're not in Zoom, you can get into Zoom by going to opencv.live. That's http://opencv.live. That'll give you a chance to participate in the giveaway and in the Q&A. That's it. Satya?
All right, so thanks for the introduction, and let's move over to Chris. And Chris, please start with a little introduction, and then we'll go over the project that you created, which made it to the top 10 of the competition. And you were also, well, congratulations that you were one of the teams that was single, a single person was the team, which is obviously very difficult, but congratulations on that as well. So take it over.
Thank you so much, Satya. Thank you, Phil. Yeah, it was a challenge, especially it was one-man band. I will elaborate on this later on, but hello, everyone. I'm very happy to be here. It's a great honor to be invited here. I'm, as already was said, I'm Chris Nogic. I live in Poland. I work in a consultancy every day dealing with Microsoft products, but I am personally involved in machine learning, advanced data analytics, and computer vision, also Internet of Things projects. And yeah, let me share the screen with the presentation about the journey I made for the 2022 competition.
Looks good.
Is it visible? Yep.
Yep. Everything looks good.
Okay. Yeah. So this is, I already said that. So this is me, and the project I worked on was the smart conveyor belt operated by computer vision and AI algorithms, AI models. And the project origin was the scenario is taken from the geological mining industry. I personally am not involved in mining or geology. However, I have a good friend that is a geologist who kind of get me interested in this kind of theme. Basically, it is about selecting different minerals from the mining output. So basically, when you pick up ore from under the ground, you have to select or sort of categorize different kind of rocks, because usually the rocks are not all the same. They need to be somehow selected, and the rubble should be discarded, and also maybe categorized to some classes.
Chris, if you don't mind, can I interrupt a little bit?
Yeah.
So before we go into the project, I think the audience would love to know your journey, because you did not start out as a computer vision, a person. Just a few years back, you were a front-end web developer. How did you make your journey from, it's almost like a career switch that you made, which, we tell our audience that that's entirely possible. A lot of people do that, and AI is taking off in a really big way. And this is your chance to actually catch the rocket ship while it's taking off. It looks like you actually did the transition. So people would love to know your journey when you started and how you got into the field.
Yeah, it's not.
Okay,
It's not
sure.
even. I think it's sometimes necessary to pivot. To change with the times, right, Satya? I think.
Yeah,
Go ahead, Chris.
absolutely.
Yeah, yeah. Well, yeah, I used to be. I started from databases long time ago, and for many many years I was a front end developer. So basically, programming jobs, web page design, and then web application design. Also a little bit of backend made in PHP, made in Node. But usually most of my work was JavaScript related, and we created lots of different projects for the front end design. And then in time, I just got a little bit tired with it because there were just new frameworks appearing. There's so much competition also in this field, especially here in Poland. And then I decided to look for something else. And because I have a background in databases, also my education was from economy, statistical, econometry, and all of these sort of came together and met again in the machine learning ideas or machine learning field. So I think it was 2017 or 16 where I started to discover machine learning concepts. First, it was purely numerical, so anomaly detection, finding some binary decision and things like that. Back then, there was no computing cloud, no Azure that you could, for example, run some sophisticated models in the cloud and calculate something biggish. You had to do everything on your own somewhere, maybe in your company, or you need to buy some graphic cards.
What a horrible time before Microsoft Azure existed. I can't imagine. I can't imagine what that was like even.
Yeah, what I'm aiming at is that you couldn't do computer vision models back then because it was simply too compute heavy, and with the growth of these services, you basically could do a lot of things by yourself and make a lot of fun of it. And if you do some projects by yourself, even for fun, you get this knowledge, and then you can hook up with some actually real life projects, right? Real companies and everything.
And you've been working as a consultant, so you had the chance of bidding for some of these contracts. Is that correct?
Yes. Yeah. Well, normally, before I worked in the company right now, I used to be a freelancer, and I was actually, that's right. I was bidding. I was maybe, let's say, competing for different projects, and this addition that I had on top of my front end offer with some AI related or machine learning related services, like for example, the engine for calculating clients' preferences, or analyzing the movement on the web page, was always giving me a little bit of the edge over the competition. Even though the models then, a couple of years ago, they weren't so advanced as they are today, right?
Right.
But it's actually interesting to come back to these projects and see how it changed, how the technology changed since like 3 or 4 or 5 years ago, and how much better you can do right now how better you can address the same problems right now.
Yeah, it's also like for people looking for career advice, I tell them that there is a very asymmetric effect of a slight edge. So you may be just 10% better than other people, but you will get all the contracts or you will get all the work because you are 10% better, right? It's almost like, in swimming, for example, in Olympics, Michael Phelps wins by less than a second, but that little edge, he gets all the gold, right? So that's actually true in the marketplace also, that slight edge. When you acquire skills and you get that slight edge over others, it has a disproportionate effect on the outcome. So that's something I just wanted to put it out there. So now we can
also
yeah.
What is funny is that, well, the machine learning or the AI projects, they have wow effect.
Yes.
So if you
Yeah.
if you showcase them, they also usually get much more attention.
That's true. That's true.
They play a lot better in meetings.
That's right.
Yeah.
Okay, let's continue with the slides.
Yeah, okay. So we started from the idea to make the conveyor belt that actually intelligently selects the proper objects, proper kinds of rocks, and they discard the rubble. And then the idea was to select or sort the remaining output, the remaining rocks, to particular classes that they were defined. The idea about the background of it is that the mining industry is not so advanced. The oil industry, for example, is very, very aware of advances. They invest a lot in technology, but mining industry is not really so advanced. And actually, if you compare these pictures from 1556 and 1915, how they sort out the output, and now how they sort out the output, it's not really much of a difference.
The ventilation has changed.
Yeah, the ventilation has changed. Yeah, but the country is irrelevant, but it usually looks very similar in nowadays. So so the idea was to take out the rocks, and I got this huge pile of rocks to select.
Straining to not make an Upton Sinclair reference here. I just did. Sorry.
Yeah, and I got this pile of rocks to select. We have three classes. So we have pebbles, we have basalt rocks, and we have quartz rocks. But it quickly turned out that there were some problems with creating a data set for training the model. First of all, the data was skewed in a way that we don't have the same amount of pebbles like the same amount of quartz. So basically, we couldn't really train the model properly. And the number of these rocks were not really large. It was like below 100 each, and the pebbles were like 300, and the quartz were like 5, maybe 50 or 60, because they are more difficult to obtain. Also, the problem turned out later on, where I actually constructed the model, the Lego model. The problem was the size. These rocks were simply too big to put on a conveyor belt, and the distance to the camera was too close, and basically they were too heavy and everything. So, to make long story short, after creating a couple of interesting models and struggling with the models for rocks, I switched to Lego blocks. So from rocks to blocks. Basically, we selected a couple of pieces that they were different classes. So there were bricks, the squares, and the wheels, or similar. So the goals were to build a real replica of moving conveyor belt, which was actually have a different speeds and have a continuous work. The other goal was to remove unwanted objects from the belt. And then the remaining objects that were not removed should be sorted by diverse classes. And they were basically taken away in different directions. Apart from that, we wanted to count objects within classes and estimate volume of the objects for each class. So using the spatial capabilities of the cameras.
I think, so if I could interject for one moment here about the goals there, I think a lot of people underestimate the importance of being intentional about your goals at the beginning of a project like this. It's really easy to think, oh, I'm just going to make a conveyor belt, right? It's not a big deal, but I like that you laid out very specific and concrete items here, because otherwise it could just spiral out of control and you end up with a half-finished, never-finished project versus this very cool, completable thing. And it's because you were partly because you were intentional about your goals from the beginning of the project, and which is great to see.
Mm-hmm, mm-hmm. Yeah, I think it's important because I also wanted to make another. You could also actually make more ideas and more goals to it, but because of the time constraints, you have to also be realistic.
Yeah, absolutely. Constraints matter.
Yeah. So the toolbox, as I think most of the teams use the same Lego set. It's Mindstorm's Robot Inventor Kit. Then I got two Luxonis Oak Delight cameras, spatial cameras. And then from the software stack, it was Azure Virtual Machines, Custom Vision service from Azure, RoboFlow for annotation and augmentation of images, and then the Python and Mindstorm's Python library for creating the actual app to run the conveyor belt and to control it.
If I could pause again real quick, I know before we started the show in the green room here, we were talking about everybody that participated in the contest is aware of this, but there was some really difficult times sourcing Legos at the beginning of this build phase of the contest. And Chris, you had a funny story about how you actually got yours. Would you like to recount this for the audience here?
Yeah, well, it's kind of funny, but usually you start to. The easiest solution sometimes works best, but when you start to, after I figured out or got the info that I won this, I got selected for the competition. I started to look for this set, and it was absolutely nowhere online to get it. It was sold out everywhere, and I even saw some private auction on the local auction service, which somebody was selling this 4 times as much.
Wow.
because of the shortage.
Yeah, part of the reason was also because of COVID. Because of COVID, people were probably, staying at home, and therefore they want this thing for their kids. That could be one of the reasons why it was sold out. We had not anticipated this. It caught us a little bit by surprise that Legos would not be available. Right.
So after looking for maybe a week for this, I simply happened to be in this mall, a huge mall. There was this Lego store, which was a tiny Lego store, and they had 2 on the shelves. They were just standing and looking at me. I just got it and just walked away,
It's like you found a nugget of gold in the mall, just in a random booth. Yeah.
And I was just walking like, what I should do, and I just stared from the alley, and it was just there on the shelf, staring at me. So, yeah, okay.
Did you hear music in did time slow down and you heard music?
Yeah.
And
That's
and your faith in God was restored.
Yeah, right. It was like my heart was up.
Right.
So yeah. It would be like I would hate to tell you I don't do it because I don't have Legos, and it would be silly. Right. Okay. So that was the prototype actually that I pitched the project with for the selection, and it was made with the Lego City. And here are the 3 images of the stages that it was built. So first, from the left is basically a conveyor belt run by the engine and the hub, and then there is this green thing is the pusher, which pushes the unwanted objects off the conveyor belt. Then the second stage was a sorter spoon, which was a rotating engine that was catching objects falling from the conveyor belt and then just tossing it off in different places depending on the object class. And then finally, on the right image, there are basically holders for the camera. There are 2 cameras, one for object detection and then one for object classification. Yeah. So the final model looked more or less like this. We used 85% of bricks from this set, all 4 engines plus the lights that that was running under the cameras to make the recognition better or more effective. Then 2 Oak Delight cameras, and it took about 2 weeks work to combine it all together with the help of my son, who had fun, creating different kinds of compartments for cameras and different wheels and stuff. So,
I heard he had fun taking it apart too.
yeah, because we were so tired afterwards, after 3 months of running this all over again, and we were so tired, and then finally it was taken, when the contest was finished, then it was just taken away in a half to create something else because it was so boring to have it for 3 months. The same. Yeah.
Makes sense, yeah.
Okay, the AI model, the image, we took about 1,000 images. Okay, we took about 1,000 objects were photographed. Okay, I mean the Lego blocks.
How did
Then
you
there were
acquire the images?
Well, I have a lot of Lego blocks. I mean, we have like tons of Legos, but not Technics, just the regular ones from the city. And I just took this whole bucket and put it on the ground and selected different classes, like those bricks and those squares and the barrels and the wheels and everything. And there was many of them. And we did different angles, and so we had about it's not 1,000, but I think 900 photos, just the raw photos. Then they were annotated, and then we augmented them. So then it was trained on the MobileNet V2 network for the transfer learning, and then the test models. Especially the test models first with the rocks, and then the first early models with the bricks were made with or trained with Azure Custom Vision, which this is a tool that I personally like very much because it's very fine tool for accelerating building projects at the early stage. You can really test it very quickly. You see what works. If there is not enough data from one category, then you add. You just generate those models on daily basis, and custom vision is very quick to do it. Then you can export it directly to OpenVino from the Azure Custom Vision, and then you can convert it to the blob.
Could you explain a little bit about most people may be thinking of Azure as a service that you get a machine on the cloud. Could you tell a little bit about Azure Custom Vision for people who may not be aware what you can do with Azure Custom Vision?
Yes. So Custom Vision is, you are right. The Azure is pretty much mostly known from the virtual machines and databases that you can put in the cloud and use them. But Azure also gives you a lot of services that are ready to go. I mean, they operate like a normal application that you would run, but you run it on the cloud in the browser. And then Azure Custom Vision in particular allows you to upload images. You can tag them, you can annotate them. I'm not sure if you can augment them there. I was doing augmentation with RoboFlow, but with Custom Vision, with Azure Custom Vision, you can definitely annotate all the pictures, and they have couple of pipelines ready for you to create certain model. For example, object detection model, classification model. They keep adding these models from time to time. This tool is being upgraded once in a while. And the thing is that you don't have to run any virtual machine additionally to this. Basically, you just click of a button, you get the trained model. It just gets trained, and there is a virtual machine underneath, definitely, but you don't really care about this. And it's very cheap tool as well for especially for those early made models which don't require too much compute power. You can create them like on a conveyor belt.
So how much do they charge only for the time the model was being trained? So that would be a good feature as well, right? When if you're not paying for the additional time beyond what the model was using.
Yeah. Yeah.
Okay.
Yeah.
Okay.
Well, you can. Yeah. This is how you say pay as you go. No, it's a different. Pay as you use or something like this.
Yeah.
Okay.
Only pay for the usage of the actual
Usage build.
compute. Yeah. You don't pay for the, and there is no fixed fee to use the interface or anything.
Interesting. And what about the time? How much time did the training take after you upload the data? How much time did the training take?
It took less than an hour, I think,
Oh,
per
so
each
that's,
model.
yeah.
That was pretty quick. I think this tool is pretty much scalable. So if there is a lot of images, like the huge amount, then they probably run a better machine underneath. So to get a better,
Right.
better.
So they are using their own pre-trained model, and then they are fine-tuning using your data, and probably also using GPUs in the back end, because if they're returning the results in 1 hour, then they must be using the GPU as well as a pre-trained model.
Yeah, for 1,000 images to be that quick, it's got to
Yeah.
be some kind of beefy hardware there in the back end.
Well, when I was using this custom vision service for other projects, I could, for example, get the model in 6 or 8 hours. So it depends on the complexity.
Right.
There is a couple, as far as I remember, there is a couple of pre-trained models to select there when you customize and put settings to build your own model. You can choose them as well. Yeah, so these were the test models, and then when I just figured out what works best, then I eventually switched to notebooks, and Luxonis gives a lot of nice demos on their webpage to use their cameras, and then I simply I ran the best machine that I could with the subscription that was made available to us, to all teams, which I think was D4S, running on Intel processor, and then we could run notebooks and then basically create models with the notebooks provided by Luxonis with some modifications that I needed. So the final model was computed in Python with the notebook, and converted for blobs to the AI platform, to the camera.
Yeah, it's best to ask for. So when we negotiate with Intel and Microsoft, the things on the back of my mind is always, what are things that cost very little to them, but it will be very useful to our participants, right? Contestants. So the Azure credits, that's, even if they gave you $500 worth of Azure credits, it doesn't mean that it cost Microsoft $500, right? So that asymmetry is very interesting, because they can give a lot of those credits, and it would be very useful for us without them costing real money.
Yeah, we try to get optimized for most bang for everybody's buck.
Yeah.
Exactly. And the thing is that because you get those credits, you can actually use everything you want. Well, there are some restrictions, of course. You cannot run like super powerful machines, although it wouldn't make sense anyway, because they would probably eat up your budget in like half a day or something.
Right.
But you can basically choose what you need, what you feel most comfortable working with, and that's what we did as well. Yeah, so the model was done. Then the brain teaser, the challenges that I had during this. So except for I never built with Technics before, and never used Oak Delight before. That was a primary challenge to actually get accustomed to these new tools, so to speak. Then the limited Python library, I will come back to this a little bit later. If you want to connect Python or make a sort of application running with the Legos, you have to have a library that kind of operates on the Lego hub. And there is a few options. People do it, and the Pybricks seems like a good alternative. Pybricks is a is a platform for programming Legos, not only Mindstorms, but different sets as well. And it's so good, obviously, that even Lego gave up their own platform, and they recommend Pybricks they recommend Pybricks to people to use it for programming. However, there is a catch with this, because with Pybricks, you have to actually update the firmware of the Lego Hub. So you have to actually put their own software to the Lego Hub to be able to run the Pybricks. And I was very afraid to do it, because I do some IoT stuff in my life. I do it quite often. I do some little, gimmicks that measure temperature or do something or measure volumes or something. And I have bricked a couple of devices in my life completely.
And this one really says Pybricks, so that's even more
yeah,
scary.
It would be silly to brick Lego bricks or Lego Hub brick.
Yeah, you can't fail much harder than bricking a brick.
Yes, exactly. So normally when I do an IoT stuff, I buy 3 things at least. So three units of the same device, for example, so that I feel comfortable if I fry one of them or fry the second. I always have a backup. But as I said earlier, we didn't have an opportunity we didn't have possibility to actually replace. If I brick the hub, I couldn't buy a spare one because it wasn't available due to these shortages that we heard about. So I didn't want to use Pybricks because of this. But there was another library that was made by one developer from Israel, which was Mindstorms library, which was very good, which was working very well. The only problem was there was no callbacks incorporated in this library. So I wouldn't know if the engine stopped running, or I didn't know the result of the event, right? I will come back to this a bit later. The belt speed limit is because I couldn't investigate. I couldn't get the information of the state of the engine because of no callbacks. I had to run the belt really slow so that all of those spoons and pushers basically managed to do everything in their time. I couldn't make any modifications in belt speed limit. Hardware issues. Unfortunately, both of my cameras were faulty in terms of they were overheating, and they were replaced by Luxonis pretty fast. But I think I spent a week or a week and a half just fighting with this. I didn't know. I thought I was doing something wrong with the code, which causes the camera to overheat. But it turns out they had some hardware problems, but they were replaced pretty quickly. It was
there was as you had mentioned before, there was a batch in which there was a bad batch in which we had up to 10% failure, and you just probably
got unlucky.
Unlucky with that.
Yeah. Unwanted detections. That's actually, I will come back to this later. The vibrations, because of the engines and the movements of the engines, the whole model was vibrating a little bit, which caused problems with the focus of the cameras. And because they were vibrating, the object detection wasn't they had problems catching it at the first go. So I had to, it was actually very interesting because that was solved in a pure engineering method. So we have to redo the way the belts and bolts are connected, and then the vibrations were simply spread differently throughout the model. And then on top of it,
having not tried this myself, could you actually put the camera on the Lego set itself so that it also shares the same vibration, or that would not have worked?
Yeah, well, that was actually the camera were held within the compartments within the same.
Okay.
You will see on the movie that it was all one entity basically,
right?
And the cameras were placed there. Yeah, and the programming challenges. Calculate moment of pusher action. Basically, it's when the object runs under the camera, it's being detected here, but it can be detected in the beginning of this yellow field, or in the middle, or in the end. So basically, we have to calculate the moment where this yellow arm, green arm pushes the right moment where the arm is pushing the object away from the belt, and that was because of the very nice capabilities of this camera that gives you a spatial coordinates, X and Y's. It was quite easy to actually catch the moment, the place where the object was detected. And then by the simple formula, because we have a constant speed of the belt, we could detect the time needed to, the delay needed before actually detecting the object and pushing it off from the belt. Then the spatial measurement, as I said on the goals page, we wanted to have, or I wanted to have also to calculate the volume of the mining output, so to speak, but in this case, the volume of the bricks. But it turned out that the camera, the OD light, doesn't really get the spatial, the Z dimension, the Z coordinate right within such a small distance from the object. So the optimal distance should be like 40 centimeters. We had only 12. So as you can
there is
see
a minimum
here,
distance. There are two things going on actually. There is a minimum distance that the camera needs to be placed at, which depends on the baseline, etc. But also there's a second factor also. When the things are very smooth and same colored, there is no texture, then its performance would suffer because it's a stereo matching problem, which does poorly when it is a solid colored object.
Yeah.
Which would be solved in the newer versions. In the newer versions, we are using both stereo as well as projection-based methods where something would be projected onto the scene so that even when the surface is plane, it can get the texture and recover the depth.
And
so
by
both those
something,
things.
you mean lasers.
That's right.
Well, that's interesting. Well, as you can see here, regardless of the color of the brick, basically the distance is a little bit too small to get the Z coordinates quite right. The X and Y's are all right, but the Z is, as you see, it's 421 millimeters, which is obviously wrong. So I saw that other teams, because initially I thought that the whole project should be built with the Legos. I got this understanding of this, but I saw other teams, they had like wooden frames, and different things like placed over, for example, the Lego model. So the solution here would be basically to have like a wooden frame and position the camera a little bit further from the belt, and then it would probably work.
That's right.
Other than that, the camera is working perfectly with the actually real size, the real life objects. The Lego blocks are really tiny, so basically this is not really the best use case for spatial detection. So that was a challenge. And then the callbacks, and you see the example here, the callbacks would be useful, for example, if I knew exactly when the engine is back, then it wouldn't happen like this. For example, I would exactly know how to operate the belt to be able to keep all the blocks in the movement, right? Not to lose any. But because of no callbacks, I just had to do a sequential programming, which is a very, old-fashioned way of very
just keep waiting for a long time.
Waiting, or basically manually placing the blocks in a fixed duration that I know that the engine would suffice and manage to come back to its initial position. And by the way, the first I skipped the unwanted detections here, like the third from the bottom. Here you can see that the sorter spoon is basically all glued, all filled with the paper. That is because this is something I didn't expect, but it's obvious that if I made a model based on Lego bricks, but the Lego bricks are very much the same, and the model was actually detecting the bricks that were the system was
It's
built.
detecting itself,
Right.
essentially.
Yeah, detecting itself, because they are so, the convolutional network is based on detections of those tiny edges and everything. And
Right.
it obviously that the Lego blocks needs to be alike because they kind of attach to each other. So they
Right.
need to be alike. So at first I was really struggling like how to solve this. I increased the number of images, but that didn't help at all. I started to also, I toyed with the idea to put the techniques blocks in the model so that I could skip those for somehow.
Yeah.
That really didn't work, and it really like it seemed like a tedious task.
Yeah.
But the simplest solutions work best, you know, if you put some paper everywhere.
Yeah.
And basically, the camera was looking at the blank. The camera field of view was filled with blank paper, blank spaces. So yeah, and it helped.
Right. The other approach could have been to use motion, because the setup is not moving and the objects are moving. That could have helped potentially. But this solution is way simpler, way nicer, actually more robust than using motion.
But it was actually detecting also the pieces of the spoon that was moving as well.
Oh, okay.
Okay, well, never mind. Yeah, it's a funny thing. So eventually we had a final result. This is the part of the movie that I as a submission that I made for the competition. So basically the prototype was working. I was quite happy with this. Not everything was as I expected. I was especially looking forward to doing some autonomous, maybe pieces of autonomous operations. So for example, if the belt would stop, if there was too many blocks on the belt, so that would suffice and manage to take care of each and every one. But,
in order to avoid the I Love Lucy problem of, you know, things keep coming down the belt and it's going too fast. Yeah. And yeah.
Yes. That was, I was hoping to be able to do this, but yeah, considering the fact that I finished this 5 minutes before midnight, then I'm happy. And I'm happy that it kind of, it proved the idea. It can be done, and yeah, it was a lot of fun to do this. So the app is calculating the number of classes. You can select which one to discard to push off the belt, and then the quantity of each block is here calculated, if it's the barrel, brick, or bumper, or wheel. And yeah, it kind of works. Nice.
That's really nice.
I think it would make an impression if we had these rocks, actual rocks there, but
excellent cinematography on this video. I just want to point that out.
Yeah, that's another piece. The presentation, the final presentation was very compelling.
Thank you. Well, yeah. I had fun shooting this in the last weekend, and yeah, we had to do this paper thing because it was spoiling the operation. But with this paper, as you can see here, it's working very smoothly.
Yeah.
Very cool.
So yeah, so that was more or less it. The lessons learned, just to close this, do not assume easy steps. So I thought the things I thought it was easy weren't really easy. Plan the time for each phase and stick to it. Yeah, well, don't yeah, if you just devote like 2 weeks to model making, then just do it in 2 weeks and then move on, because basically you can simply spend like the whole time just doing one thing. Start from the most problematic step. That was for me a lifesaver, and do not do it alone. I mean, that was a bad idea really, to, even though I had help from my son and from my daughter who was annotating images. Really, that was the other thing was basically, if I had another person on the team, we could really split the work much better, and it would be much more effective, and perhaps it would be done in a better way.
Yeah, big shout out to both your son and daughter for helping you out in the project. Their contribution is, much appreciated.
Yeah, we'll have
Yes,
to make
yes.
sure
Cool.
to give them certificates when we do the top 10 finalist certificates, which I'm working on. So
Okay, very good. Thank you. I will surely pass it on. Yeah, okay. Thank you so much. Thank you so much. It was fun. And thank you for the opportunity. It was really a good adventure and a lot of experience gained.
It's our pleasure. Should we go with
yeah, we can only
audience
provide
questions?
opportunities. Yeah, let's so go Chris, go ahead and unshare your screen if you don't mind.
Sure.
So I'm going to do quickly here. I'm going to do our teaser trailer first. So
Oh,
we're going to do our giveaway directly after what I'm about to show you, which is a teaser of the new virtual set that we've been working on with our friends at Light Twist. I know we've been talking about it on the show for a few weeks, and so we thought we'd let you kind of wet your whistle with a look around. It is currently on YouTube. I'm posting the link in our chats, and I'm about to share the video to everybody watching here live. All right, so I'm going to hit the intro, and then we'll
so maybe explain.
Hey everybody, it's Phil Nelson here, the co-host with the co-most, and I'm here with the regular host with the regular most, Satya Malik. Satya, what do you think about this awesome virtual set we've got here with Light Twist?
I think this is a great set, and I'm really excited to see, this new virtual set. We had used this in OpenCV game show, but this is now going to become our regular feature in OpenCV weekly webinar. I'm so excited to see this virtual set. And with us in the studio is Vikas Reddy, who is the
That's right.
creator of this virtual set. Vikas, we'd love to have you here. A few thoughts
Hey,
how you
Vikas.
built the set, and what do you think?
Yeah, really, really great to be here in the studio with you guys. Yeah, it's been fun. The Light Twist team has been working really hard over the last couple of weeks to pull this together. We're actually streaming from the cloud, so all of us are streaming up to a nice GPU server in the cloud. We're running some nice segmentation, some different computer vision algorithms there. So a pretty cool combination of 3D graphics and computer vision that we pulled together. Yeah, the team is really excited to be participating in this with you guys, like helping power this experience, and super excited to see all the awesome guests you'll have over the next couple of weeks in the space on this very screen.
Yeah, so you mentioned the cloud there. Does that mean I'm in the cloud? And if so, how do I get out of here?
You're actually, if you read the clause of the contract that we signed, you're actually obligated to stay in the cloud for at least another 6 to 7 months. So
Am I real?
Get comfy.
Is any of this real?
What about the cat? Is the cat real?
The cat is, yeah, it's a question. But what is real?
So next, it's time let's do our giveaway. Thanks for sticking around here, everybody. If this is your first time joining us, or if you just need a little reminder, every week I ask a trivia question, which one lucky person in the audience wins something for. This week, because it's an episode about OpenCV's spatial AI contest, we will be giving away $200 of Microsoft Azure credits, thanks to our generous sponsor at Microsoft Azure, on blazing Intel D4 hardware. If you have won in the last couple of months, please do not answer and give other people a chance to win. Get ready to answer here in the Zoom chat. Earlier, Chris talked about training models on Microsoft Azure and how fast and easy it was. About how long did he say it took to train his model on the Microsoft Azure Custom Vision Service? I had a streak of a couple weeks of people, being a little bit stumped, but they were just on that one. So I'm looking at the responses here. Bob Flynn is the most technically correct of the first responders here. Daniel said 1 hour. Cruz said 1 hour. Vasnath said 1 hour. The actual answer was less than 1 hour. The answer. So Bob Flynn, you have won some Microsoft Azure credits. Please send one email to phil@opencv.org, and we'll make sure you get your Azure credits pass. Let's move on to questions.
I have one more announcement before we go for the questions. So Independence Day, we have a sale for our courses. So, watch out for that. People who are interested in computer vision, deep learning, these are the courses that OpenCV offers. And we have very few sale events in a year: Independence Day, Thanksgiving, the Black Friday sale, and maybe the New Year's sale. So there are only a bunch of these. So if you're interested, please watch out for the newsletter email.
Yeah, and space is always limited. It's first come, first serve. So you want to get in there quick to speed your way through learning. That's opencv.org/courses, by the way. Moving on to questions from the audience here. For Chris, you noticed you mentioned you used MobileNet, SSD MobileNet V2 as your detector. Did you try other models, other methods, or did that one just happen to work out for you?
Yeah, I tried YOLO as a part of this mass production of models through custom vision, and MobileNet just proved to be slightly better, just performed slightly better.
So the performance was better without losing any accuracy or whatever?
Yeah. Well, the parameters accuracy were basically higher. You see, in my opinion, the number of image samples was not very high. So basically, it doesn't really. I think what would work best is to significantly increase the image samples. That would be the main way for me to actually, and the MobileNet or YOLOS was basically a secondary problem.
Gotcha. Stephen would like to know, what sort of challenges did you have with regards to labeling and annotation? I know you said your daughter was helping out with that. Would you care to expand on how that process worked for this project?
Yeah, the problem, because we spent a little bit too much time on labeling and on basically training the model over the rocks themselves. Then when I got panicked a little bit, so I need to switch to Lego bricks, and then we had this. Well, we had to label this in a rather short amount of time, so I could all hands aboard. So basically, I needed all the help that I needed, and it's actually pretty easy to do in RoboFlow. In RoboFlow, it's the annotations are very. It kind of intelligently places the annotation box from one image to another, and it just goes very quickly. So yeah, my daughter was very fast with this as well, which was a great experience for them as well, I think, hopefully.
There's another question in the top, Phil, you might have missed. How many Lego Mindstorm kits did you need for this project? Was it single kit sufficient?
Yes, we used 85% more or less of the pieces from this set.
Yeah, so the question was from Kumar.
Yeah.
Par would like to know a little bit more about vibrations and the speed of the belt. Like, did you change, how did you zone in the speed of your conveyor belt, and also tell us a little bit more about how you managed to handle the vibrations and get past that issue?
So as for speed, as I said, because we have no callbacks to verify what is the state of the engine, what is the position of the engine, we had to wait until the engine finishes its movement. I had to put the belt speed at almost the slowest possible setting, which was 20. The whole engine movement of steering is based on it goes from 0 to 99. So 99 is the fastest, 0 is stopped completely. And because I had to put the objects on the belt in a particular delay, then the speed 20 was basically a fixed speed, so it was working best on this. 30 was already too fast, and 10 was really slow. I mean, 10 was like almost like a snail, so it would take forever for a brick to travel. And as for vibrations, yeah, that was solved in two ways. First way was to completely rebuild the how to say, the legs of the model, so the pillars that it was basically standing upon. First, when the vibrations were very big, the legs were basically mostly vertical. Then we switched a little bit to this diagonal shaped a little bit, and the more diagonal bars added between different parts, it kind of helped to support the vibrations resistance. And then at the end, perhaps it was seen in some maybe images, there was a LED block positioned on one engine. The pieces of LED basically taken from a model train. I disassembled model train, took this Lego, which was very small but very heavy, and put it on one engine, and it like reduced the vibrations by maybe 50%. And it was already enough. The vibrations were still visible, but for cameras, it wasn't an issue.
That's great. I like the ingenuity there. You know, you use whatever you got to solve the problem. I like it.
Yeah.
So we're getting close to the time here. Chris, if folks want to follow you on the interwebs, you know, ask you questions, what's the best way for them to do that?
I think the LinkedIn profile would be the best. I am getting messages there on a daily basis. So there was a link there.
Yeah, well, I'll make sure I put it in the show notes there.
Okay. Yeah, please feel free to use it. Yeah, I'll be very happy to answer any questions if somebody has it, for the project.
Awesome. Yeah. Next week, our guest will be Anna Petrovicheva, again, talking about a very exciting new release from Model Place, which you may remember from an earlier episode of OpenCV Weekly webinar. So look forward to that. There's been some big changes coming over there, and it's a really exciting resource for stuff very much like this. Satya, you want to take us home?
Yes, I want to thank Chris for joining us for the submission, and it's very motivating for people who are starting out to see such neat submission, such great presentation. So thank you for that. Also want to thank you, Phil, for organizing this webinar and also the OpenCV Spatial AI competition. And thanks a bunch to our audience. We love you, and it's great to see you every week. It keeps us motivated. So until next week, adios.
Absolutely.
Thank you.
Thanks one more time to our generous sponsors at Microsoft Azure and Intel, or Intel and Microsoft Azure. See, I swapped them around there. Take care of yourselves out there, folks. Take care of somebody else if you can.
All right.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by Intel and Microsoft Azure as part of OpenCV Spatial AI Contest. Follow along with the OakDLight Contest hashtag. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.